We don't do a lot of quadratics in grade 12. We only basically draw some linear and quadratic in Excel and try to find the equation for them. So we don't do a lot of quadratic work in grade 12, thank goodness. But still, it's good to know these things, especially if you're gonna move on to college and take some math in college, because that will be it. So just to quick review between linear model and quadratic model. A linear model is a straight line. When you have a table of value and you do the first difference, your first difference is going to be constant. Okay? So I don't know if you guys remember with a table of value. So you have your x and y values, right? The x values are your independent variable, okay? And y is your dependent. So once you find your y values here, so let's say your y values are like 2, 3, 4, whatever your y values are. Once you do your first difference, so y2 minus y1, so you subtract your y2 minus your y1. If your y2 minus y1 is constant, so you have the same variable, that means you know it's a linear function. So that's in the case if you have a table of values. Okay? As a graph, if you have a straight line, then you know that this is a linear model. And then as an equation, you're going to have some kind of value, 2x5, let's say. Your degree on the x is 1, so you know it's linear. Okay? So there's 3 ways that you can look at it. As a graph, it's going to have to be a straight line. Table of value, you have to do your first difference. And then in an equation, you should have a degree 1. Okay? Quadratic is a little bit more challenging. Quadratic, you have 3 different ways that you can write a quadratic equation in. So not only one, like technically this has 2 different equations. But. So you have standard form, which is ax squared plus bx plus c. You have the vertex form, which is ax minus h squared plus k, and you have the factored form. How many of you remember these forms? You just got out of NBF 3C, you should know this. Okay? How many of you remember some of this? No? Am I just like, because I need to know how much actually, you know what? I'm not going to go too much in detail for this because you're not going to use it. Okay? Just so you know, these are the 3 different formats of quadratic. I'm not going to go too much in detail because you're not going to need it in grade 12. Not even in the tech math. They don't even do anything quadratic. Okay? So this is more like the grade 11 basic. Okay? So, but at least when you look at the equation, you should be able to identify if it's linear, quadratic, or not. Okay? So if it has a degree 2, then you know it's quadratic. Okay? And then when you have a table of value, if your second difference is constant, then this is, you know, it's quadratic. And then the quadratic look like this. It's a parabola shape. It can be like this, or it can be opening down, right? But it's a parabola shape. That's the shape of a quadratic. Okay? So if you see it, you should be able to identify it. Okay? So if I look at this one, right here, can you tell me if this is quadratic or linear? It's quadratic. You see that on the x, the highest degree that I have is degree of 2. Okay? Because that degree of 2 is right there, that means I can tell that it's quadratic. Because your highest degree is that everything is like simplified and there's no like terms, because otherwise you're going to have to collect the like terms. If I look at the second one, I won't be able to tell right away if it's quadratic or not. Yes, you want to jump into the conclusion that it's quadratic, but I can't actually say it's quadratic because it's not written in the most simple form. Okay? I have to make sure that everything is simplified. I only have one of each term, okay? And then I can decide. So this is not simplified at all. If I want to simplify this, what do I have to do? Expand the brackets? No, not factoring. FOIL. That's right. So you wanna put all the x terms on one side and you wanna put the y terms on the other side. Okay? To put the x terms on one side, I can't do it unless I get rid of these brackets. To get rid of these brackets, I have to FOIL. Okay? So I feel like I am okay, to FOIL this, multiply the first by the first, outer, inner, last. Okay? Now you see that I want to have the x's all on one side and I want to have the y's on one side. Because technically it should look like this for me to be able to tell if it's linear or quadratic. I can't tell yet. So there's two things that I need to move. I need to move that y over so it's with the other y. And I need to move this 2x over so it's with the x's. Okay? Because you need to have the like terms together. So if I move that y over, it's going to become minus y. And if I move that 2x squared over, it's going to be negative 2x squared. And I'll write the rest as is. So what's 2y minus y? You have 2 apples and you ate 1. 1 apple, right? So 2y minus 1y, that equals to 1y. Yeah? Okay. Where are my like terms on the second side? So this one and this one, right? What's negative 2x squared plus 2x squared? What's negative 2x squared plus 2x squared? Zero x squared, which is 0, right? So these cancel each other, yeah? Because minus 2 plus 2, that's 0. So I have no x squared term. Negative 14x minus 3x, these are like terms. So that gives me negative 17x plus 21. Now you can say if it's linear or quadratic because now it's in the most simple form. So what is it? Linear. I don't have x squared. Right? If you right away looked at this and said, oh, it's quadratic, there is an x squared. I'm going to say no. Right? Because it's not in the most simple form. You can't decide before you try, before you put it in the most simple form. Okay? And I know this is linear because the exponent that I have on the x is 1, right? So this is using basically your knowledge of algebra to for C, I have a graph. What shape is the graph? It's a parabola. And we said that parabola are the shape of which function? Linear function or quadratic? So quadratic, right? So right away, by looking at the graph, I know it's a parabola shape. Parabola shape are symmetrical shape, right? They open either down or open up, and they're symmetrical around the axis. You guys know what a symmetry is, right? When you cut something in half and you fold it, they overlap. Okay? So this is a parabola, so I know because it's a parabola, I know it's quadratic. When it's a table of value, I can't decide unless I do my first difference and my second difference. Okay? We're gonna do some of this again when it comes to the graphical model. So we're gonna see this again, and I would like you to know it because I'm gonna expect you that you know this. Okay? So when I do the first difference, basically I take my y values and I subtract the bottom minus the top. So that's y2 minus y1. So I take the y value, the bottom one, and I subtract the top from it. So that's going to be 7, take away -2. So that's 9, because 7 minus and minus, that's positive, so that's going to be 7 plus 2, which is 9. Then what do I do? 16 minus 7. What's 16 minus 7? 9. What will be my next one? 25 minus 16. That means it's linear. Okay? But I have to show all of them. I have to make sure that it doesn't fall off the trend. And because your first difference is constant, it's the same value, I know it's linear. Now, what happens if the first difference is not constant? Can I right away say it's quadratic, or do I have to do something else? I have to check the second difference, which means I have to subtract the first difference from each other. So I have to go 9 minus 9, 9 minus 9. But in this case, I don't do that. So I know this is linear because the first difference is constant.